So while we're on the subject of seismic activity, this is actually a divergence from the idea of a shear wall. And in this case, we're not trying to make the building as stiff as possible because that could lead to failures in other points of the building. This is a great example of a tuned mass damper system in a building that we've actually already looked at. This is a 111 West Street, West 57th Street. It has a terracotta cladding on it with a bronze filigree. I've mentioned this in class and kind of went through that when we were talking about rain screen and terracotta systems. And in this case, this is an ultra-thin building for the uber-rich apartments on Manhattan overlooking Central Park. And so we see at some really high floor level here, which I'll point out on with my cursor here. We have the tuned mass damper system. And we can see it in cross-section here through the building. And this is a good 3D view of it. And the idea here is to reduce building sway. This could be from wind loading or could be in the event of seismic activity also. It's kind of notable that this building has already been completed and there are complaints already about the building sways being really uncomfortable in these upper floors. So the idea with the tuned mass damper system is to a mass system. So the building, if you think about it, the building starts to move. The mass that's held here doesn't want to accelerate as fast because it weighs so much. So it tends to want to stay in position while the building moves. And when it goes through that kind of an excursion where the building is moving independent of the mass now starts to, the building is actually, dislocating from the mass system. These hydraulic dampeners are being extended. The fluids that run through these absorb energy and then try to dampen the motion or the swinging of this. Not unlike what would happen if you were to put your finger on the fret of a guitar while you were striking a note and hearing a higher pitch. So by controlling the relationships of the mass damper to the building, you can control the frequency and the amplitude of the oscillations of the building. So it's kind of a neat and very expensive system. Obviously, part and parcel with the kind of high-end construction that we're looking at with these kind of tall, slender buildings. Maybe a more simple look at ways to think about structural systems. In our project, in our modular project, we did a mass timber modular building. And I kind of advanced that with the idea of looking at an adaptive truss-based shear wall system. The idea here, and this project's available, I don't assign it, but if you're interested in doing it, you can. Is just to model and come up with the concepts for these braced timber systems. Why we want to introduce braced timber stiffening in this kind of building is to reduce the carbon footprint. We're obviously building the building out of heavy mass timber in order to have a lower carbon footprint. And if we have to create shear walls that are made out of concrete, we're really kind of defeating our purpose. So in this case, we look at creating these bracing systems. And then in order to deal with the idea of fire isolation, we can go back and create fire-rated assemblies using gypsum board instead of concrete. So it's just a methodology, and I'll explain a little bit more about these shear walls in another slide or so. And I'll just finish off this clip with the idea that a lot of this analysis about shear wall performance really becoming very automated, and useful tools are available to us and our other people that we work with, our consultants, our engineers. In this case, it's Rhino, but we can easily see this being Revit and using Rhino in Revit. And the software that's doing the analysis is Carumba. And it's a sophisticated mechanical engineering structural analysis tool to just generate this idea of understanding all of these shear walls and what they do to contribute to the overall stiffness of the building assemblies. So the second key word is with cream.